sir. I wanted to ask if there are any free spaces in this course.
No, sure, there is no.
There is.
Huh?
It's full.
It's full.
It's full. Okay.
No problem. Hey. Yes. Are you registered? Yes. Yes. Yeah. Well, if you are still registered, you are still registered. No, no, there is no need for the number. You are registered, you would be in this list. Yes. If you, sorry, if you, once If you were in the waiting list, uh, please, and you haven't signed up, please come after the class, okay? After class to sign up. Okay, if you were in the waiting list on Thursday and you've been added to the course, please come after class to sign up. Is that clear for everybody? You did not sign up last week. If you are registered, okay, no. There are people who were registered on Thursday and they are still registered. Those people are in the course. There are people who were in the waiting list on Thursday and on Thursday were registered after class. Okay? If you are in that group, you should come after class and sign up because you haven't been in any class so far, so you cannot be officially registered until you attend the first lecture. But the first lecture for you will be the second lecture. Is that clear? So if you do not sign up this paper, you will be again deregistered because there is still people waiting. Okay? So if you are already registered and you came on Thursday, you are definitely registered. If you are registered because you were in the waiting list on Thursday and you come today and you sign up, you are definitely registered. If you are not, if you do not sign up today, you are again deregistered. Any questions on this? Okay, to verify registration, you need to attend the first lecture. In this case, the second lecture for those who were in the waiting list. Did you write the number thing? And you are not there registered? You left for health reasons and okay, then you should sign up after class. Okay, this is another case that I didn't. If you were excused on Thursday, for health reasons, and you came today, please also sign up. Okay, if you were excused on Thursday. Any questions? No? Good, so then let's start with the lecture. So, what were we doing? So we were thinking about preferences and choices. Okay. Choices, that's what we observed. Preferences, some sort of construction that we are going to use. It's not what we don't really observe them. Okay, but so what are choices? Well, there is some set of choices, capital X. This is what you can choose from, and then little x is the choice that you make when you faced with the set X. Right? So that means when you see options X, which is a collection of items, you choose the item X. Yeah? And what we want from these choices is that they are rational, okay? In the sense that they don't contradict each other. So when we see an individual making various choices, okay, so he faces choice set X, and then faces choice set Y. This is another choice set. We don't want this person to, in some sense, choose in a way that we would consider inconsistent, internally inconsistent. Okay, internally inconsistent. And what is that? Well, it would be well, that is when, if you choose X when confronted with the set X, and y is available in this set. So little y is a possible choice you could have made when confronted with the set capital X. Then if X is in some other set Y, so the second set, you look at it and little x is still available, it cannot be the case that y is the choice of y. So let me see if I explain this again. So the axiom of internal consistency called warp says, if you choose little x when confronted with the set capital X, and y was available to you, then if x is now available to you in the set capital Y, it cannot be that now you choose y, little y, because little y was already rejected. Okay? If you fulfill this criteria, we're going to say that your choices are rational. Okay? They are, at least, they are not internally inconsistent. On the other hand, we have preferences, and these are rankings over alternatives of the sort x preferred to y. This is, to some extent, quote unquote, what we want. Okay? We do not see this. We see choices in reality, but this is something that is sort of in the back. And there is some sort of idea of a ranking. X is preferred to Y. The individual, in some sense, has a preference, has desire, is some sort of reason to choose, for whatever reason, the person would say, well, between X and Y, X is better for me. Okay? In whatever sense that is. And we want this to be complete. So then you can do this for all alternatives. Okay? You can do this for all alternatives. For instance, you can have the set of voters of parties in an election, right? In Austria, you have the FPÖ, the OVP, the SPÖ, the NEOS, the Grünen, the Bierpartei, etc., all the parties, and you have a ranking of those alternatives. The one you like, for every 2 parties, you can tell me which one you like better. Okay? And so this ranking X preferred to Y, and I'm going to say 2 things. One is complete, that the ranking is complete. So you can always tell me which one is better. Okay? An incomplete ranking cannot tell me which one is better. Sometimes. Maybe sometimes it can, sometimes it cannot. So we are going to say that it is complete. And most important, it is transitive, so that if X is preferred to Y and Y is preferred to some other thing Z, then we want that X is preferred to Z. Okay? We want these 2 things to be true. For it to be referred to as a proper order, as a proper ranking over alternatives. We want that we can always tell, and we want that the ranking is transitive. Now, we discussed this transitivity the other day. I'm not going to do it now, but it is a difficult condition to hold. It's not so straightforward, but we're going to assume it. Okay? And now the revealed preference theory says, well, if there exists some ranking of choices of alternatives that justifies your choices if and only if this axiom holds, this thing holds. Okay? So that means if your choices fulfill this criterion, this condition that we have here, then we can find a preference for you that would justify your choices, that would make your choices meaningful as a person who wants to fulfill this objective. Okay, so for instance, you choose. Let me just give you a very simple example. You choose the number 20 rather than the number 12. You choose the number 9 rather than the number 7. You choose the number, when you have 9, 7, and 5, you again choose 9, okay? So these are choices that you are making, and you can check that in all these choices you don't violate any internal consistency. And then I can identify some ranking that is actually behind your choices. What is this ranking? Well, in this case, I was always choosing the largest number. Okay, so the person is faced with these number choices, and as long as the person does not violate internal consistency, I can always find an objective, a ranking over alternatives that justifies the choices in the sense that these choices have now a purpose. If when I had the choice between 9 and 7, I chose 9. But when I had the choice between 9, 7, and 5, I chose 7. That means I violate internal consistency because 7 was available before, but it is chosen now. And 7, and therefore, I do not satisfy this criterion. And if I don't satisfy this criterion, there is no way you can find some ranking, some preference that makes sense for me. Because sometimes I prefer 9 to 7, sometimes I prefer 7 to 9. That doesn't align with our goal here. Okay? So you cannot say, you could say that they are just as good, okay? But the simple definition I'm having here does not include ties, okay? But other than the case of ties, you know, which for now we can forget, if sometimes I prefer 9 to 7 and sometimes I prefer 7 to 9, you cannot say that I'm fulfilling any objective with my choices. Is this clear? That's what we did. That's what we did last week. So, in economics, the canonical set of problems that we will face are not choices between numbers, are not even choices between parties, are choices between baskets of goods. Okay, quantities of goods that we purchase, that we demand, that we consume in the market. And in principle, we can have up to L different goods, and L can be any number. Could be 6, could be 100. In the economy, there may be thousands and thousands of goods. Okay, and a bundle or a basket of goods is a vector, okay, with L elements, one for each good, that tells me the quantity I consume of each of those goods. Okay, so for instance, the first element is how much I consume of good 1 kilo, 1. The second element is how much I consume of good 2. That's apples, and I measure it in units, so that's going to be 2. And then the number L is the last element, let's say beer, and in liters, 2.551, whatever number, okay? Now, in the course, everything I will tell you is it's enough if I use just 2 dimensions. So L is going to be 2, but nothing that I tell you is going to be specific to L equal 2. So anything you could do with more goods is just more cumbersome, and we cannot depict it. Okay, so there is nothing to be lost by looking at L equals 2. But in principle, one can have as many goods as possible. What is the advantage? Well, we can represent it in a diagram. You must have seen diagrams like this, where you have the quantity of the goods in the axis, okay, the quantity of the goods, and a bundle is just a point in this vector. So for instance, this bundle is 3 units of good 1, because that's the quantity of good 1, and 2 units, in this case, 1 unit of good 2, that's a good 2. Okay, any point in here represents some quantity of each of the goods, and in principle, we can consume any quantity here. Can we consume quantities here? No, why not? Negative. So can we consume negative quantities of a good? No, well, it depends on the good, yes? In principle, there are goods one could borrow, okay, or own, not really consume, but at least own a negative amount. Okay, so you could own a negative amount of a good. For instance, in the stock market, you can it's called short sell goods, or you can borrow goods because you are speculating that the price, for instance, is going up. Okay, but in this course, we are going to think more simple problems of consumption in which you actually consume the good, so negative amounts will not be relevant. Okay, so we will be focusing on the positive orthant on this quarter here of the graph. But in principle, one can have negative quantities as well. And there are many problems that fit in this setup. Of course, choosing how much to work and how much to consume, choosing how much, one of the goods is, which would be the goods in the case of when you choose how much to work and how much to consume. What do people want to do? They want to consume. Consume is good, right? And do they want to work? No, what do they want to do? Enjoy their time, enjoy their leisure time, okay? So that's a case in which, in a sense, the good, in this case, work is a bad, the omission of the bad is the good, which is leisure, okay? And what happens with leisure? Can we have infinite amount of leisure? How much leisure can we have? Well, depends on your specific formula, but in general, we cannot have more leisure than time we have to live. Okay, the most time I can spend in my leisure is the time I have to live. Okay, so you can write it in different forms, you will see, but you have to think that in this case, in the case of beer and cheese, in principle, one can consume infinite amounts of these goods. Now, notice that in the reality, in the real world, there is not infinite amount of beer. There is only finite amount of beer. But at least it's conceivable for me that I would drink infinite amount of beer. Any amount of beer I could think of drinking, even if it does not exist. Okay? You could think that you could consume, but you cannot consume more than 1 day of leisure today. It's inconceivable to consume 3 days of leisure today. Right? You can consume up to 1 day of leisure, half a day of leisure, 2 hours of leisure, but not 2 days of leisure today. Okay, so that's a constraint in how much you can consume a good. This could be a maximum amount for this good. Okay? How many children to have, and how much to spend on them. Okay, this is a problem that economists have studied a lot since at least Gary Becker in the 60s, where they think about the choice that people have of fertility in the family. Should you have 10 children and all of them being half naked, or should you have 1 child and be a spoiled brat? Yeah, so that's basically the choice that people have, and that choice, different people choose differently, of course. And the number of children, you can think of the expenditure per child is, of course, a continuous variable, but the number of children, can we have 0.2 children? No, not really, right? It's either 0, 1, or 2. Now, there are ways we can think of the problem as more continuous in the sense, but for now, at least, one can think of this problem as being similar. You have to choose, the number of children is kind of 1 or 2 or 3, and then how much to spend on them is really a continuous variable. Another one is how much to save for tomorrow, how much to consume today. So this is one that is very common. And if you are taking macro, you will see this problem a lot. Okay, a lot. How much you save today so that you have for tomorrow, how much you consume today. That's what you don't save today. And finally, how much to put in the bank and how much to invest in stocks. That's called a portfolio choice problem. If you take courses in finance, you will see this problem a lot. These are all problems that fit in this domain because mostly there are 2 goods in these examples. You could have more goods, but it's not relevant. And the quantities, what you are choosing is really quantities of these goods. Okay, quantities of children, quantities of leisure, quantities of savings, which means consumption tomorrow. That's what you care about, not really the saving, but the consumption tomorrow. And you also have how much to put in different assets, okay? Which to some extent acts as, different goods, yeah? To some extent, you can think of it like that. Okay, so let's go back to our reveal preference question. Okay, so you have now a choice set, C of X, and I repeat it with this oval. And the blue point here is my choice, little x, yes? Feasible set is big X, the choice is little x. That's what the individual wants to do. And you see, for reveal preference, you always have to ask yourself, it's not enough one choice. One choice can never be violated. You can choose whatever you want. But once you make a second choice, a third choice, a fourth choice, your choices will start becoming more limited if you want to satisfy the criteria. So now you have a new set Y, is this circle to the left of the oval. Okay, I use unfortunately the same color, but I guess you get it. So C of X, your choice before, is it available or not? It's still available. Belongs to this circle, belongs to the oval. It's in the intersection of the two sets. So it's available, okay? So that means that you can apply the condition. Let's say the person chooses this point. Does this person satisfy the action we gave of reveal preference? No, why not? Why not? Right, because this choice, this point here, was available before. But the individual chose this point. This point is now available. So the individual should not go back to this point that she discarded before. There is no reason for her to do that. Yes? So if the point that before, yeah? So notice where C of Y is. Let me put the hand there. So if you go back here, the hand is disappeared, but it was here, right? The hand is available. The person says no to the hand, but now I give him another choice, and the person says, actually, although this is still available, I want to switch now. That's inconsistent with the weak axiom of reveal preference. Okay? Which choices would be consistent with the weak axiom of reveal preference? They would be choices in this area. These are possible choices. We do not know which ones, but we know that they should be here. Only those. Only those. No, underneath here, no, because these are not feasible. Okay, let's go back. The set X, the oval, right, is available in the first problem. In the second problem, only Y is available, this circle. So these choices are not available. You cannot choose what's not available. You can never choose something if that option is not given to you, right? So you can only choose points in Y. We agreed that points like C of Y are not what? Are what? Are not consistent. They fail to satisfy warp. They would lead to an sort of, they are irrational, okay? But points here, they are not irrational. They are consistent because you actually could not choose those before. So you didn't tell me that you didn't want them, in some sense. Forget about, intuitively, you didn't tell me that those are not good for you because you chose something else. Are these the only points, these points that you could choose now and not violate rationality? Consistency. We can stay where you are, okay? This is what maybe you forget. You can also choose the same point. You can be a very stubborn person, a person who always answers the same every question. Okay, a person who does that is consistent, okay? is consistent. That person always has this preferred choice and never switches. That person is perfectly consistent. So it's either this point or this area. Or put it differently, if you switch, you switch to this area, but if you stay, but then you stay. So now let's think about a bit of a stronger question. If you were to, you don't know this person, but you like this person, let's say. This person is a nice person. And you were to ask yourself, forget about this choice CY, because this choice CY, we know this choice CY is not consistent. The person now understands that she shouldn't choose C of Y. And so now I give you the options between set X or set Y to give to this person. Suppose you were the policymaker and what you could choose is to give the person to choose from set X or from set Y. Which set would you give the person to choose for? You understand the question? No? Suppose you are when you are a policymaker, basically what you are giving people are choices of this. You basically are choosing for them their options. You make some things illegal. Things that are illegal shouldn't be in the choice set of people. Okay? If you legalize marijuana, you make something that was not in the choice set opens the choice set. Okay? That's what you do as a policymaker to some extent. You choose for people their choices, their available choices. And then they decide which ones of those they prefer. Okay? So now you can choose for them to present them with the set X or the set Y. And you know that the person in the set X chooses this point. And forget about this other choice, because this choice we agreed they won't do, it's wrong. And the person now knows this. So you can choose to give the person the set X or the set Y, and you know that from the set X, she chooses this point. What could you do? So you say you choose X because we know what she would do. Yes? To give more options. In which sense there are more options? Both are many options, no? There are many points in both. Sorry? Yes. Yes. Okay, yes. The explanation is not perfect, but I get your point. So what do? You should give her Y, indeed. Why? Why should you give her Y? Well, if you give her Y, she can either stay. If she stays, you didn't harm her, but she moves. If she moves, she's telling you she'd rather be here than here. Well, if you give her X, you know she chooses this. So if the person is rational, only if she's rational. But if she's rational, then you know as a policymaker, you should give her Y. Because indeed, as he says, Y has more options, more relevant options, more options that are not dominated by X. Okay? Why? So we know that in principle, the set Y is an improvement for her over the set X. If she's rational. If she's not rational, no. Because notice that when she was not rational, she chose something that was dominated. And actually that made her worse. That happens sometimes. People giving them more options, people say, oh, too many options may be bad for you. Well, that means you are irrational. If you are rational, too many options cannot harm you. Okay? Because you can stay in the same option that before. It's just there is some irrationality involved there. But if you are rational and you get more options, that cannot harm you. And because it cannot harm you, Y, in a sense, gives you more options because it gives you the option X. That's just everything that was in the circle X is in some sense worse than this. But then you get some alternatives additional. Maybe they are useful, as you say, maybe not. Do you all see this? And so why is this very important? Well, we could make this argument now, this reveal preference argument, that the set Y is better from the welfare perspective than the set X. policy Y is better than policy X. Okay? Better for this individual because worst case scenario, it did not harm. Likely, maybe it improved. Okay? And this we can obtain without asking this person any question other than what? What do we know about this person? What did we know about this person? Preferences. Do we see her preferences? Did I? Well, we assume that she is rational for now. We are going to assume that during the course. This is very important. If she's not rational, we cannot make this inference. This is very important. What else do we know about her? No, about cheese or no, we don't know whether she likes this or that. No, we do. This is not. Well, why? This point is not. She could have more cheese. Yes, not that she likes cheese. No, it's not important that. And also, we don't see what she likes. We see what she chose. That's what we see. We know that this person chose this point. When confronted with the status quo policy, she chose this point. And that's enough for us to conclude that policy Y will make her happier. And that's the power of revealed preference that economics uses. From one choice, that is actually what we see. We didn't ask this person any question. There is no survey. We didn't ask how much you like cheese. Do you not? Do you drink? Do you don't drink? Maybe because of religion. We don't know any of that. We just saw one choice that she made in one case. The real world, what we see now, in the situation that the person is in, she chose this point, and we can conclude something about an alternative that never happened. It never happened. Why? It never happened. But we know for sure that if the person is rational, the new policy that never happened is better. Do you see this? This is really the idea of revealed preference. Use what you see that people do, infer what they want, and use that to design something better. Okay? Okay. So we have choices, we have preferences, and there is something else that people talk about, and it's called utility. Now, utility is the most boring of all of this, but it is like, it's like a pasta dish. It's nothing fancy, but it's very useful, okay, to have. To know how to do pasta is not great, invention, but okay, it's very useful. Nobody says, oh, I'm so great, I do amazing spaghetti bolognese, but it's a very, very useful food to have, okay, on a Sunday morning. So the utility is the same. It's nothing new, really. There is nothing interesting in the preferences. Everything is in the preferences. Everything really that comes from preferences is in the choices that we can see. Preferences we don't see. And utility, but preferences exist. And utility does not even exist. Okay? Utility is just a construction. It's a representation. Okay? The utility is just a representation of the preferences. Why? Because to describe the preferences, I had to describe rankings of alternatives. X is better than Y. Z, 10 is better than 7. 5 is better than 22. Whatever numbers, okay? I have to describe you a lot of comparisons. And that's tedious. That's very boring. Okay, so instead what we can do is we can use a utility function that is a representation of those preferences that it is faster than all the comparison. Okay? It's a way to represent the information in the preferences in a simpler way. Okay? That's what the utility function will do. Okay? So we have to assign a number for every alternative x. We assign a number u of x such that if x is better than y, u of x is greater than u of y. So it's just a way to say, I like apples better than bananas. Or I could say 1 apple gives me 5, 1 banana gives me 3, 5 is more than 3, therefore apples are better than bananas. Okay? There is nothing really, this number can be arbitrary as long as it satisfies this restriction. Okay, that's just a simple way of representing the information in the ranking. You represent it based on the utility. For instance, if you just have n alternatives, remember with n parties, for instance, how do you do this? For instance, you have this ranking, x is better than y, which is just as good as z, and z is better than w. Well, one utility function that works is to use x. You see x, there are 4 alternatives. X is the better of the 4, so I'm going to give her 4 points. Y is the second best of 4 alternatives, so I'm going to give it 3 points. C is also the second best of 3 alternatives because it's just as good as Y. I'm going to give it 3 points as well. Notice that I have to give Y and C the same number of points because they are just as good. So I need that Z is bigger than U of C is bigger than U of Y is bigger than U of C, so they must be equal. Okay? And then I'm going to give W 2 points because it's the least valuable option among all of them. Okay? That's just a point system. It's just a way of numbering things. So if I know that U of X is 4 and U of W is 2, I know for a fact that X is better than W for the individual. Now, does this 4 or this 2 mean something specific? Is 4 twice as much as 2? Does this mean that the individual likes X twice as much as he likes W? Does this mean that the individual would rather have 2 W's than 1 X, or just indifferent between 2 W's and 1 X? No. All that it says is that X is better than W. All that it says is there is a ranking. In no way this ranking is meaningful in that way that it is sort of what we call cardinal. There is no cardinality to this. In no way being very close or very far in points has a meaning beyond the fact that more is better. Okay, so for instance, the ranking V of X, so X gets 19 points, W get minus 200 points, and Y and Z both get 13 points, is in a sense the same ranking, is exactly the same ranking, and so in a sense, V of X is just like U of X. This function V of X captures the same ranking with completely different numbers. Notice that the range is much bigger, and this even have a negative number here, but this negative number is not really meaningful. What matters is 19 is more than 13, 13 is just as much as 13, and 13 is more than minus 200. That's what it matters, and that's what it's captured in this order. Now, what would happen? What would happen if the preferences are not transitive? Let's think about it. What would happen if your preferences were not transitive? So, for instance, if X was better than Y, Y was better than Z, but Z is just as good as or preferred to X. This is a ranking of alternatives. You can always compare all 3 alternatives. If you face between X and Y, you like X. Between Y and C, you like Y. Between C and X, you like Z. Yes? We cannot find numbers that would fulfill this criterion. Why? Because if you give, so you have to give X a number compared with Y. How should the number of X compare with Y? Bigger. The number of X should be bigger than the number of Y. So for instance, let's call this number 10. Let's call this number 5. Y and Z. How should the number of Y be compared with Z? The number of Y should be bigger than the number of Z. So if this is 5, this number has to be smaller than 5. And what does the last one say? Z should have a number bigger or smaller than X? Bigger. So U of Z has to be greater or equal than 10. Can this happen? No, you can't find it. That's why we need transitivity mostly, not only because, so it turns out that you need transitivity, which you also need to be able to derive these preferences from choices. Okay. So if your preferences can be derived from choices, and your choices are rational, then you can find a utility function that justifies them. Okay? But you see that the utility function, these numbers are completely arbitrary. It's just that it's a convenient way of representing the ranking, and that convenient way could be found as long as your choices are consistent. Okay? Now, some of you know about utilitarianism and utility, and these seem to be connected terms, and they were originally connected. This is Jeremy Bentham, who's been mummified in University College London. He's sitting there, waiting. And he attends every meeting. When they count the votes, they say, well, 7 votes in favor, 3 votes against. Jeremy Bentham doesn't vote. Since the utility function, so as I said, the utility function is just ordinal. Bentham came up with this idea that the goal of society, you see, before we talk about policies, and in which way did I take, I told you that the policy was good here, right? We discussed this policy Y versus policy X. And the policy Y, I said, was better. Did I use any utility idea here? It's better in the sense that the individual can fulfill her wishes better. And that is consistent with the general idea of utilitarianism in the sense that we are considering something good if it is useful in some sense, if it helps people achieve goals. And in that sense, it fits with the idea, utilitarian idea, of attaining some sort of measure of happiness for people. But we didn't have any happiness measure here. All that we had was the idea of revealed preference. Now, Bentham thought of policy's goal to be to maximize some sort of sum of utilities of people. Utilities by thinking, he talked about pleasures and pains. The society should have as much pleasure as possible and as little pain as possible. Yeah? And you can think of the utility in some sense in his mind as the difference between the pleasures and the pains. And so in that case, you could think of whether this utility that kind of fits into that story. But the reality is that it doesn't, because this kind of sum of pleasures minus pains is completely arbitrary. So for me, the utility that represents my preferences may be, it may be that for me, I prefer X to Y, Y is just as good as C, and C is preferred to W, and my utility function is this. Okay? But you, with the same preferences, have this different utility function. Okay, that's your utility function, supposedly, in this world. Okay, and now, when asked who should we care more about between you and the other person, well, in some sense, my choices are almost meaningless because I can only move from 4 to 2, while your choices are very meaningful because if you choose right for you, you get 819, but you choose wrong, you get minus 200. So in some sense, you would matter much more. We will see in which sense you would matter much more. But what you can see here is that the measure of the utility is not meaningful. The only thing that we get is a ranking of alternatives. Okay? But for an individual, not for society like he was thinking. This was, society requires aggregating across people, but for a single individual, the concept of utility is simply a representation that may allow us to perform what's called counterfactuals, so alternative policies. Okay? Evaluate those counterfactuals. See whether those alternative policies are better or worse. And they're in the sense that we can compare their subjective well-being, not in some measure of actual utility, but rather in whether they are allowing the individual to fulfill their goals better or worse. So before we had this with Y was a better policy than X because it allowed the individual to fulfill her goals better. Now, this is very simple with a few choices, but how in reality most of the choices we make, there is so many of them. There is not 4 options. There are many options. There is an uncountable number of options. You can buy 1.112 liters of beer or 1.1119 or whatever, in between. So you have to choose all these very detailed things, and you cannot list them all. There are too many options to be listed. So that's called uncountable. Too many options to just list them all. So the system we did before was to rank them by putting the best at the top, second best, third best, list them all, and give them points accordingly. But that doesn't work here really, because when you have so many options, you cannot find a number for every option because you cannot list them all. So how can we think of utility functions in the world of bundles? So let's go back to our bundles here. Remember, there are so many. Each point in the graph represents to a possible bundle. This point and this point and this point. So many points, you cannot see them all, of course, but they are all there and they are all possible. The individual can choose any of them. And so we want to know how much the individual, how the individual compares those possible combinations. And for that, we typically use what's called indifference curves. Okay, that's a way to represent the preferences of the individual in this world. So what is an indifference curve? Well, an indifference curve is a curve or a locus, is a line, yeah, that contains all baskets that the individual considers just as good as this one basket. So for instance, this line means that every point in the line is just as good as 3, 1. Okay? All points in the line are just as good as 3, 1. And that gives us some idea of the preferences of the individual, okay? Because generally speaking, the individual will be happier when she gets more of both goods and unhappier when she gets less of both goods, right? So if you think about it this way, by depicting this line, I can answer the question. I figured out this line somehow, and now I can ask the question, does the individual prefer this bundle or this bundle? So does he prefer 3-1 or 2 or 1-2? 3-1. Why does he prefer 3-1? No, we don't see utility here. Well, you can say, but okay. How do we see this graphically? That's my question. Huh? How do we see why did you make the conclusion that this point is worse than this point? Yes? Is it? Yeah? Okay, that's better explanation. Okay, let's go with that. From point 1-2, I could give you a bunch of stuff of both goods. You could get a bit more cheese. You could get a bit more beer. This clearly must be better for you. From 1-2, you can move up in both directions and get to the line. Right? You get to the line by getting more of both goods. And if you are in the line, how is that point compared to this point? It's just as good, not equal, just as good. So this point is just as good as this point, and this point is clearly better than this point because it gives you more of both goods. And in this world, you like better more cheese and more beer, and so we know that this point is better than this point using transitivity, actually. So what we use is that this point is just as good as this point. So this point is weakly better than this point, and this point is weakly better than this point, so this point is better than this point. Does this make sense? So we make the argument using transitivity here, And that actually shows that just with this picture, we can tell a lot of things. We can tell whether this point is better than this point, or this point is worse than this point. We cannot tell really whether this point is better or worse than this point. This we cannot tell, but we can tell quite a few comparisons just with this line. Okay? For mathematically, this is the level curve, okay, the level curve, if you want, of the utility function. It tells you which are the points that have the same utility. Okay? So for every, along every point, there is an indifference curve. This is the indifference curve that goes through 3, 1. This is the indifference curve that goes to 1, 2. Can these indifference curves cross? Why not? In this course, it doesn't, answers like yes and no don't give you very far, okay? You have to say yes because, no because, why not? What is the, why would this not be consistent? What property would be violated? Transitivity, very good. Why? Suppose you have a crossing. Here, this clearly you would improve moving up. So this point is clearly worse than this point. So let's call this A and B. So B is better than A. And clearly, C is just as good as B. Okay? C is just as good as B. Now, D here, compared with A, what is D and A? A is also clearly better than D. No? Because you move along the diagonal here. And D, I think I put too many points, but it's not important. D is just as good as E. But now E must be better than C. So B is better than D. Forget about A. A was redundant. B is better than D. B is just as good as C. And C is worse than E, but E is just as good as D. So this is not transitive. Okay? There is a reversal. You are just, so between B clearly has to be just as good as C. So B is worse than than E. And B is just, and B is clearly better than D. But D and E are just as good. Yes? No, this is because this is an indifference curve I depicted. This is one curve and this is another curve. I depicted them so that they are different indifference curves, but they are crossing. So you must have seen a map. Have you ever, if you do walking in the mountains or something, you get a map, and in the map there is this level that tells you the height at which you are in the mountains. Okay, and you see all these little lines, and they are, typically closing like a circle. They don't have to be exactly a circle, but they close themselves, and they never cross. Okay, because if they crossed, they would mean that a single point has two different heights. And that is inconsistent. Every point has only a height above sea level. And in the same way, every point has a single utility level, cannot have two. So there is no way in which the lines can cross. If they did, they would violate transitivity. And if they violated transitivity, there wouldn't be a utility function. Now, the last part of this is why this helps us. I told you the question is, can we find a utility function that represents the preferences when you cannot list all alternatives? And the answer, in some sense, is yes. You can find them by doing the following logic. Think about the diagonal. Okay? Each point in the diagonal is characterized by a certain quantity of goods that is the same for both goods, right? So a point here has a certain amount of good 1 and the exact same amount of good 2. That's a point in the diagonal, right? Okay. And any 2 points in the diagonal, by definition, one is strictly better than the other, right? Because one of the 2 points will have more of one good than the other. This is less of both, this is more of both. So the point that is farther along will be better, okay? But you have a lot of different levels. And each indifference curve will cross at a single point, the 45-degree line, the diagonal. Okay? It cannot cross at 2 points, because if it crossed at 2 points, you could figure out that one point will be worse and the other point will be better, but the same indifference curve cannot have 2 different levels. So there is a single crossing on the diagonal. And now you can call the utility associated with this point the amount of each good that you get in this bundle. For instance, this point has this amount of good 1 and the same amount of good 2. And this point in the diagonal, that's one number, tells you that if you have the same, this amount, let's call it 7 units of each, you are on this point. That point is on this line, so you can call the utility of this line 7. And if you are on a higher level, 8, you must be up more, you must be in a higher indifference curve, and if you have a lower number, you will be on a worse indifference curve. So by doing this construction, you can construct a utility function for any preference that you have on this bigger set with some additional assumptions we are not going to discuss. But roughly speaking, what we need is that every point is indifferent to some point on the diagonal, so that these lines cross the diagonal. Okay? That's the only thing you need. And so that's how you can think of the utility function. It's a representation of the level of the indifference curve here. And higher number, whatever, is better. You can call this 7, you can call this 7 million, or 722. It doesn't really matter, okay? It's just a representation, it's just a way of determining the level. And in economics, we typically have problems in which individuals, as I said, the individual problem, we started with this, is determined by a set of choices available, set of alternatives that are available, and a choice. The preferences and the utility function tells you how you compare those. And we saw an example now with many baskets. But the question is, what determines what you can consume? What determines what you can consume? Okay? And now, of course, this depends on your society. If you live alone in an island, you can consume whatever is available to you there, whatever you can produce yourself, and so on. But if you are in a society like Austria, you can acquire things in the market. Okay, you have some income, you are given often some goods, right? By the government, you know, public transportation or things like this. Well, you have to pay for public transportation, but parks, things like that. There are some things that are free, but many things, you know, you have to purchase in the market. So your available choices, in some sense, are the things you can afford. Okay. So this is what in economics we refer to as your budget constraint, is the set of elements, the budget set is the set of elements you can afford. Okay? And that is what determines your available choices. Your available choices are not going to be typically some oval like we did before, but they are going to be determined by your budget. And everybody's free, okay, in the market economy, but some people are more freer than others because they have more money, okay? That's the fact of life. Some people have more money than others. Those people can buy more things. They have more choices available to them. You have less money. You have less things available to you. So what is special about these choices that are available? Well, they are going to be, you know, combinations of goods, X1 and X2 with two goods, but more, you know, could be more goods. And the question here is going to be very simple. It's going to be, can you afford this combination? Is this combination affordable to you? And this is an accountant could tell you whether it is affordable to you. Okay, there is no magic here. So what do? You say, well, I have some income W. I have some income W. And therefore, what is affordable to me is any combination of goods 1 and 2 that doesn't spend more than W, where the expenditure is determined by the prices P1 and P2 of the goods. So if apples cost 2 euros per apple and bananas cost €1 per banana, the number of apples times 2 plus the number of bananas times 1 has to be less than my income. If it was more, I couldn't afford it. Okay? If it is just the same, I can afford it, I spent all my income. Okay? And so the important thing, of course, and you have seen this 100 times, but I mean, you know, I do everything. I told you the course is self-contained, so I do everything, is to think about the budget line. So, of course, we have a line depicted. So you have an equation like this that is linear in X1 and X2. And what you can do when you have an equation that is linear in two variables is to solve one variable as a function of the other. So if you isolate X2, you get W over P2. P2 goes to the other side, minus this goes to the other side. Okay? W, your quantity of good 2 is W over P2 minus X1 times P1 over P2. Okay? What is the slope of this line? What is the slope of the line? Minus P1 over P2. Okay? The slope of the line is minus P1 over P2. And then to find the two axes is very easy because when you are in the axis, you only purchase one good, so you spend all your income on that good. So that's very easy to find what are the axes. And the line gives you the slope, which is minus P1 over P2. Okay? So what is W over P1? Well, W over P1 is how much cheese you can buy with your income. W over P2, how much beer you can buy with your income. And the ratio P1 over P2, the price ratio is what? It's the slope of the line, but how could you tell me? Suppose that the price of apples is 2 and the price of bananas is 1. What would be the slope? Okay, let's call this, let me use the same words. Cheese, the price of cheese is 2, the price of beer is 1. What is the slope? Minus a half. Why? What does the half mean really? No, that's just these points here. Those are the points. I'm asking the slope is minus a half. You agree because you just replace here. No, sorry, minus a half, minus 2, no? So P1 is 2, price of cheese is 2, price of beer is 1, so the slope is minus 2. What does it mean minus 2? Why minus 2? Yes? It's the exchange rate. If you were to give up 1 apple, how many bananas could you buy? If you give up 1 apple, that apple costs 2 euros. Not an iPhone, it's an apple that you eat. So it's 2 euros. And with those 2 euros, how many bananas can you buy? 2. Okay? The slope tells you how much can you exchange these goods. Because you could say, look, I can eat more of one and less of the other. I can eat more cheese. Okay? But that requires giving up bananas. If the price of cheese is very high, I have to give up a lot of banana, or in this case beer, for a bit more cheese. And if the price of cheese is very low, I have to give up a lot of beer. Now, the price in isolation doesn't really mean anything. Okay? What matters for the slope is the ratio of the two prices. Okay, is the ratio of the two prices. So when people say some product is expensive, hopefully what they mean is that it is expensive relative to other things. Not that it is expensive in absolute terms. That doesn't make any sense. For if you say, yesterday, maybe some of you are Austrian and read the news, it was in the Standard, the newspaper here, they said, you know, butter has never been more expensive than now. Okay, why? Because the price of butter in euros is a ton of butter is 7,000 euros. Never been so high. Okay, never been so high as 7,000. Does this make any sense? What information is contained in that statement? Relative to the historical price of what? Of the same good, compared with what other good? The statement is, butter has never been more expensive. It is now 7,000 euros per ton. What are you comparing here? 7,000 is what? Huh? What is this price? I say, butter has never been more expensive. The price is 7,000. Relative to what? No, the quantity is 1 ton. So now it's 7,000. A year ago was 6,000. So the price of butter is now 1,000 more. But what does that mean? Well, maybe supposedly relative to the budget. Did they compare it to the budget? Did they say, well, the budget now of Austrians is so much, and relative to that budget is so high? Did they say that? In euros. 1 euro in butter is worth less than it was a year ago. But 1 euro in any other good, is it worth more or less than a year ago? Less. So unless we compare it with other goods, do we get any sense of how much this is? People say, oh, this is more expensive. No, it's not. The number is bigger. The number is bigger, but unless you tell me another price of something that did not change. So they said in the news, bakers are very upset because the price of butter is so high. You know what else is more expensive? Bread. You have to say, look, it has never been the case that baked butter has been so much more expensive than bread. Okay? Croissants, you know, you use a lot of butter in the croissant. If the croissant was cheap and butter was expensive, that would be news. But you can say, well, relative to the income. Okay, so you can go back to medieval times. And how many days did a person have to work, an uneducated person? Because in medieval times, most of us were uneducated if we were alive then. How many hours does the person have to work to pay one kilo of butter? A person would have to work a week to buy 1 kilo of butter. Do you have to work a week to get a kilo of butter? So when you say that it has never been more expensive because the amount in euros is higher, is this meaningful? Is it? No, because you need to compare it to something that makes the comparison meaningful. What matters is one price over the other. Your price over a wage, your price over the price of something else. Just to say that a number is very high is meaningless. You can't change the currency. Many countries experience changes in the currency. They all of a sudden eliminate 3 zeros Because they had so many zeros, they took up 3, 9, 18 zeros. Okay, somebody here from Zimbabwe, maybe they saw this. One day the government of Zimbabwe says if you had $1 million, now you have $1. Okay, we changed because the numbers were so enormous. These notes were enormous just for the zeros that they had to carry. So they just took them out. And now the news say, Neva Bata has been cheaper. This is meaningless. Meaningless. Okay, and the good thing of these sets is that it's just like the before, but they have this nice structure. The line defines the feasible set. Before we had these ovals and stuff, they are nice to look at, but they are not real. What is real is the budget line. This is feasible, this is infeasible. This you cannot attain. Some people have more freedom than other people. If your budget line is very small, you may be free in the market, but you are not very free. If your budget line is far away, you can afford many things, you have more freedom. Okay, you have more choice. You can choose other things than some people cannot. Okay, infeasible, feasible. Okay. So now we combine the two things. That's how we do it. In economics, we combine things. We combine preferences and constraints. Most of what we do in economics is combining what we want, what we can. And then we find what we should do, what is good for us. When we think about what is the best thing for me among the things that I can do. So these are my preferences, this is my curves, and this is my feasible set. And so there are 4 options that I can consider here: the orange dot, the green dot, the blue dot, and the black dot. So now, when I look at this, what happens with the orange dot? No, can't afford, too expensive. What happens with the blue dot? Can you afford it? Yes, but you know, you would actually could improve by buying more of both goods. You know, you are just throwing away resources in a sense. Now, you can think of saving, but if you were to introduce saving would be itself a good. So this is more like throwing away stuff. Throwing away stuff, not what we are in the business of doing. Okay? So blue is worse because we could get more of both goods. Okay? So you don't need to look at the map of indifference curves to know that. Blue is bad, orange not affordable. What about black? What about black? Black is feasible and doesn't throw away resources. But how is black compared with blue? Is it worse than blue? It's just as good as blue. Just as good as blue. Now, if black is just as good as blue, and blue was worse than some other bundles that you could throw away, clearly black cannot be the best choice, because there are choices up here that would dominate blue, and blue is just as good as black. So black is also not the best choice. What about green? The green is the best choice, and you know the picture, so you can identify always green, but why is green the best choice? It's in a higher indifference curve than what? You consume all of your budget, but that was also true in black, no? It's better than any other options, but how do we see this? Okay, because the proper answer is any indifference, any other bundle, any bundle that is on a beta indifference curve is not feasible. Any bundle that is above green is not feasible. Okay? Any bundle that is feasible is on a lower indifference curve. Okay? Any bundle that is feasible is on a lower indifference curve. Now, I will finish with this. What geometric property does the green bundle have? There is a point of tangency. The indifference curve is tangent to the budget line in the green point, meaning the indifference curve is touching a single point. It's not crossing, but it is touching the indifference curve at the green point. And when you have the tangency of a line, a straight line and a curve, what happens there? What happens when you have a curve and a line and they are tangent in a point? Yes, back in the back? The ratio is? Ratio is 0. Okay, the slope is the same. At that point, the slope of the curve is the same as the slope of the line. The slope of the line, by definition, is always constant. It's the ratio of prices. And at that point, the slope of the curve is the same. Okay? Is the slope of the line. So in the green point, the slope of the indifference curve is the slope of the line. What is the slope of the line? The price ratio. So the slope of the indifference curve in a point is the price ratio. And what is the slope of the indifference curve? Yes? Okay, we will see this next week. On Thursday, sorry. Come on Thursday. Now, stop. If you did not come on Thursday, but you are registered, come to the front and sign up. If you don't sign up and you didn't come on Thursday, you would lose registration. Please come to the front and sign up. You have to sign up? You were here, you took the, yes, the numbers.
I did not sign. Is that okay?
Yes, yes. Your name is here? Petro. Here, sign.